So what we're going to do today is we are going to look at how we can simplify expressions where we have an exponent on a set of brackets. Now, the rule that we can use for this is an expression with an exponent on a bracket may be simplified by multiplying the inside exponents with the outside exponent. What does this look like? Well, here's a question that you could encounter out in the wild. You were walking through the scrub on Route 63 and a wild expression suddenly appeared. It was defined as being 2, let's go 4x to the 3 y, all to the power of 2. We haven't seen this case before. We've seen multiplication, we've seen exponents, we've seen division, but we've never seen brackets have an exponent on it. Now, does anyone remember what does an exponent actually tell us about what it's on? If we have an exponent of 2, what does it tell us about this bracket here?
There's 2 of them.
Yeah, it tells us that there's 2 of them. So this is the same as saying that there are two of them. Now, if we wanted, we could write as many of these out as we need, and then we can simply use the rules we already have. But that is too slow for us. We're better. What we're allowed to do is we're allowed to use this new rule up here. Whenever we see a bracket with an exponent on it, then every exponent inside the bracket will be multiplied by the exponent outside the bracket. So 2i's 2 is. Let's go down. Next line, it's going to become 2 because that's outside. We're not dealing with that yet. Inside, it's going to be 4x to the 3 and then y. Now, what is the exponent on the 4 here? Any ideas? Tegan, your hand went up. What's the exponent on the 4? 1. And the exponent on the y is 1. So when we're doing this, it's going to be 1 times 2, 3 times 2, and then 1 times 2. Because every exponent inside the bracket is multiplied by the exponent outside the bracket. We take care of what we can do, the multiplication. So this is going to go 2, 4 to the power of 2, x to the power of 6, y to the power of 2. Next line, 4 to the power of 2. Do we know what that is? 4 4s.
12. 16.
16. And therefore, we are allowed to bring the 2 inside. 2 times 16 is 32. And all of a sudden, something that is quite cantankerous looking is reduced to something that is slightly less cantankerous looking. Are there any questions? So the rule is, whenever we see an exponent on the bracket, we multiply every exponent inside the bracket by the exponent outside. So 4 times 2, 3 times 2, 1 times 2. Anything outside the bracket, leave it alone for now. Bedmass tells us brackets first. Anything outside, leave it till the end. Wait till the brackets are gone.
You missed a bit.
Where?
Where you just tried to bring it out. No, no.
Down.
No, like,
Yes, got it.
What's a tough this one? Thank you.
B. Or do you want to go straight to C?
It's Is C more harder?
Yes. B.
C.
Okay.
Are you still recording?
Yes.
I got you, I'm recording, buddy.
Still recording. Now, in true fashion, we've done something that's reasonably straightforward. Let's jump to something that's like death. Okay, we have minus 2x to the power of 2. Then inside the brackets we have minus 3, x to the negative 5, y to the 4, and that bracket is to the power of 3. Now looking at this, what does our rule tell us, Matilda? What do we do whenever we see an exponent on a bracket? What do we do whenever we see an exponent on a bracket? What does our rule tell us to do?
You multiply the inside exponents with the outside.
Bingo, so what do you reckon we'll do here? We will multiply the inside exponents by
2.
the outside exponent, which is 3. So let's give that a gander. Outside the bracket, we have minus 2x squared. We can't do anything with that because there's nothing to be done yet. So we leave it as is. Anything we can't do anything about, we just write it down and leave it. Next, we have a minus 3. We have an x to the minus 5. And we have a y to the power of 4. What we're going to do is, using our rule, everything inside the bracket is going to have its exponent multiplied by the exponent outside the bracket. So this 3 over here is going to go on that 3 there. We don't have to put the 1 because we know anything multiplied by 1 is just itself. Next, this minus 5 is going to be multiplied by 3. And the 4 is also going to be multiplied by the 3. Next, we have to be a little bit careful. On the next line, we're going to start dealing with these here, and we'll probably deal with this minus 3 cubed. Does anyone know what minus 3 cubed is going to be? Won't be 67. 3 times 3 is 9. 3 times 9 is 27. But it's minus 3 cubed. You have to be very careful when you're dealing with exponents on negative numbers. When you put it in the calculator, sometimes they don't give you the right answer. So put brackets around your negative before you put in the exponent. All right, next line. I'm not removing that.
Yes!
Okay, this is going to be negative 27. Okay, next step. We're getting ready to get rid of the brackets altogether. Ladies, focus please.
I'm sorry.
To get rid of the brackets, it's going to turn into a times symbol there. Or you can use the brackets, it doesn't matter. I prefer brackets personally. Then, it's minus 2 times minus 27. The x squared can go at the end. We've got an x to the power of negative 15. We've got a power or y to the power of 12. Take care of the multiplication. Sum the exponents of the similar variables. 2 by 27 is 50.
54? 5.
6.
7. No. Oh, wait.
There's your simplified answer. Again, if you want to go one step further,
Ow! What the hell?
Talia, focus please. If you want to go on further, you can write what's in blue, but there's no need. You haven't actually simplified any further, you've just changed the form it's shown in. If you get what's in green, or if you write what's down below, perfect. But remember, what rule did we use to expand this open? What rule did we use, Paige? Exponent on the brackets. Whenever you have an exponent on the bracket, you bring the exponent in and multiply it with all of your exponents inside the bracket. That's our rule. Now, in the future topics, you're going to see something slightly different where this won't work. It's a different case. But for now, whenever we see exponents on the bracket, we bring, every exponent in the bracket is multiplied with the exponent on the bracket. Is that cool? Does anyone have any questions? Annabelle?
So when are we going to use this in the wild?
When are you going to use this in the wild? Well, when you're a physicist and you're trying to write the equations for 11-dimensional reality, you'll probably have to use it then. For most of you, unlikely. I rarely use this if ever. Even when I was an engineer, I rarely use this. I could not tell you when I use this. But quiet. Ask a question, get an answer. But it's not about the rule, it's about problem solving. Every time you see something, you have to problem solve. When you're out in the wild, you won't get that specific example, but you're learning the skills right now to problem solve anything that you could get. We can't teach you what you'll get out in the wild because we don't know what you'll get and it will be new. You have to solve problems that haven't been solved before. So it's a good question. The answer is you probably won't see this specific case unless you're a physicist. Talia? Yeah, of course.